Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to all of you. Today, I'm MOHAMAD FARIS bin ZAINUDDIN, Nur Mimi SAZIRA BINTI ZAKARIA, MOHAMAD HASHRIQAL DANISH bin ABDUL HALIM, and VANESSA CHRISTY ANAK BEGELI. We will discuss about the assignment fluid mechanics set B. So for the first question, we had been asked about the bubble that come up from the oxygen tank by the scuba diver. So we need to explain why the bubble rapidly rise to the sea surface and what happened to the size of bubble after it breathed out underwater until it reached the sea surface. And the answer is, when in underwater, the ambient pressure around is increased. When a scuba diver breathes from the oxygen tank, the lung become more pressurized to match its surrounding. The bubble breathes out underwater, rise to the surface quickly due to the decrease in pressure. The external water pressure acting on the bubble decrease as the bubble rise because water pressure increase with the depth. The decrease in the bubble surrounding pressure allowed the bubble to expand, hence making them bigger in size. In simpler manner, as the bubble rise, the depth increase, the pressure decrease. So to equalize pressure inside the bubble with the outside water pressure, the bubble expand to lower the pressure inside. Boyle's law states that as the volume of gas increases, its pressure decreases. The bubble exhaled by the scuba diver grows as they approach the surface of the ocean, meaning to say the bubble gets bigger and bigger. The pressure exerted by the weight of the water decreases with depth, so the volume of the bubble increases as they rise. That's all from me. Thank you. So let we move to the next question.
Assalamualaikum warahmatullahi wabarakatuh. I am Mimi, metric number MA21076. Today I want to present question 2. For question 2, the figure show a glass of ice filled to be brim. Will the water overflow when the ice melt? Explain your answer. To solve this problem, firstly, we should answer the first question, which is, will the water overflow when the ice melt? Based on my knowledge, the ice float because the density of water more than the density of ice. However, water will not overflow as ice melt because when the ice melt, it produces the same amount of water which is it used to displace. So, the volume of water remains same in the glass.
Assalamualaikum and good evening. I am Muhammad HASHRIQAL bin ABDUL HALIM with metric number MA21078. Want to present and show how to solve question number 3. So question 3A is determine the absolute pressure in pipeline. So we from the question we can get P oil equal to P air minus rho oil GH oil minus rho mercury GH mercury, and we can expand and get like this. Okay, so from the equation we know all the value except the P air, so we must find the pressure of air. So we can determine the absolute pressure in air tank from ideal gas relation with PV equal to MRT, and then we put the V to the right side and will be like this. Then we just insert the value and then we will get the P air. So after we find the P air, so we can find the absolute pressure in the pipeline. So we just insert the value and we get the answer. Now for the 3B question, determine the change in the level of mercury in the manometer when the air temperature in the tank drops by 30 degrees Celsius. So first, we must find the PA after the temperature become 30 using the same equation like 3A, and we get the answer. Okay, now we can say that when the mercury level in the left arm drop a distance c, then the rise in the mercury level in the right arm b, and so we will get this. Now to find the mercury level, we can write like this, and we just insert the value, and then we can get the answer. That's all. Thank you.
Okay, moving on to question 4, our last question. So the question is, a 5 meter long quarter circular gate of radius 3.5 meter and of negligible weight is hinged about its upper edge A as shown in figure 3. The gate controls the flow of water where the density is given 1000 kg per cubic meter over the ledge at B, where the gate is pressed by a spring. Determine the magnitude of resultant force and its orientation acting on the gate when the water level rises to A at the upper edge of the gate. So from this question, we have 3 infos. The first one would be H, which is 5 meter. Second is the radius, R, which is 3.5 meter. And then the density of water, or represented as rho, which is 1000 kg per cubic meter. So first of all, we need to find the forces acting on the vertical and horizontal surfaces. So for the horizontal force on vertical surface, we have F hash equals to Fx equals to rho g hash A. So that would be 1000 times 9.81 times 3.5 divided by 2, and then times with 5 times 3.5. So that would give us 300.431 exponent 3 Newton, or 300.431 kilonewton. Okay, so the next one we need to find is the vertical force on horizontal surface. So that would be Fy equivalent to rho g hash A, also equivalent to rho g hash at the bottom times A. So that would be 1000 times 9.81 times 3.5 times 5 times 3.5. So that would give us 600.862 exponent 3 Newton, or 600.862 kilonewton. Okay, next we need to find the weight per 5 meter length, and that would be W equivalent to mg, also equivalent to rho gv, also equivalent to rho g times r squared minus pi r squared over 4. So that would give us 1000 times 9.81 times 3.5 squared times 1 minus pi over 4. So we will get 25.789 exponent 3 Newton, or 25.789 kilonewton. Okay, next slide. Next, we need to find the net upward force, which is Fv equivalent to Fy minus W. So just now we have calculated Fy and also W. So that would give us 600.862 exponent 3 for Fy minus 25.7 789 exponent 3 for W. So we will get 575.073 exponent 3 Newton or 575.073 kilonewton. Okay, next, the resultant force. Resultant force is represented as Fr, and that is equal to the square root of Fh squared plus Fv squared. So we have the square root of 300.431 exponent 3 squared plus 575.073 exponent 3 squared. And we will get 648.82 exponent 3 Newton or 648.82 kilonewton. Okay, next we need to find the direction of the force. So that will be the tangent of theta equivalent to Fv divide Fh. So just now we already defined Fv and also Fh. So over here that would be 575.073 exponent 3 divide 300.431 exponent 3. That would give us 1.914. We are not done yet because this is only the tangent theta, but we are looking for the theta. So over here, we press on our calculator as shift tangent 1.914. So we will get theta equivalent to 62.42.